Hello everyone and welcome to my new lesson video. In this video, I will be discussing the first topic from the first unit of AP Chemistry or Advanced Placement in Chemistry, and that is all about moles and molar mass. So I will discuss why is it important to determine the number of moles of a substance as well as what is a molar mass. So join me in the next few minutes and learn something new about chemistry. I am your teacher, Sir Mark Laroya. Here are some of the topics under the first unit of AP Chemistry, and the first unit of AP Chemistry is all about atomic structure and properties. So the first topic, or that is unit 1.1, is moles and molar mass, which I will discuss in this lesson video, followed by mass spectroscopy of elements. 1.3 is the elemental compositions of pure substances. 1.4 it's the composition of mixtures. 1.5 it's the atomic structure and electron configuration. 1.6 photoelectron spectroscopy. 1.7 periodic trends. And for the last topic in unit 1, the valence electrons and ionic compounds. So first question is, how do we quantify substances? Or should we say, how do we measure the quantity of a substance? Usually, we determine the mass or volume of a substance. Most of the time for solids, we use mass. And in often cases, for gas and liquids, we use the volume. We can also quantify substances in terms of number of particles, in terms of atoms, molecules, or ions. But quantifying substances in terms of particles is actually not practical because the value is too large. That is why we have the number of moles of a substance. It is a quantity of a substance that contains the Avogadro's number, which is 6.02 times 10 raised to 23 particles per mole. So, once we determine the number of moles of a given substance, we just simply multiply it with the Avogadro's number, so we will know the actual number of particles of that substance. We use this number of moles in different concepts in chemistry, like in ideal gas law, stoichiometry, concentration of solutions, as well as in colligative properties. So in terms of number of particles, we use atoms if our substance is in terms of element or ion, and molecules if our substance is a compound or diatomic element. So let us consider these three different substances. We have calcium carbonate, sodium chloride, as well as sulfur. And then let's say we're going to weigh these three different substances, and we found out that the mass of calcium carbonate is 100.09 grams. For sodium chloride, it's 58.44 grams, and we have 32.07 grams of sulfur. We notice that they have different masses, but given these different masses for these three different substances, all of them have the same number of moles. We have 1 mole of calcium carbonate, we also have 1 mole of sodium chloride, and 1 mole of sulfur. Even though they have different masses, they have the same number of moles. It is because the given mass for each of the substance is their particular molar mass. So for calcium carbonate, the molar mass is 100.09 grams, and sodium chloride it's 58.44 grams, and for sulfur it's 32.07 grams. So for the equivalent mass, or should we say the molar mass of a particular substance, give us 1 mole of that substance. Either a molecular mass or atomic mass. Before we proceed with determining the number of moles of substance, let us first discuss the molar mass. Sometimes it is also known as formula mass. So molar mass is the mass of a substance which is equivalent to 1 mole of that particular substance. So we have two different terms used for molar mass. The first one is the atomic mass, if our given substance is just an individual element or simply an element, and then we use molecular mass if our substance is a compound. So how do we determine the molar mass of a substance? So it is easy to determine the molar mass for a substance if it is an element, because it is simply the atomic mass, and you can easily determine the atomic mass because it is already written in the periodic table of elements. And then if we have a substance which is a compound like this, for this next example, determine the molar mass of magnesium chloride. First, we have to make sure that our chemical formula is correct for us to determine the correct molar mass of a substance. So the formula or the chemical formula for magnesium chloride is MgCl2, and to determine the molecular mass, which is the molar mass of our substance, we simply add all of the atomic weights of all elements involved in the chemical substance or compound magnesium chloride. Since the chemical formula is MgCl2, meaning 1 particle of magnesium and there are 2 particles of chlorine. So atomic mass of magnesium plus twice of the atomic mass of chlorine. So the atomic mass for magnesium is 24.31 grams per mole. That is the unit of our atomic mass, and this will be also the unit for our molecular mass, and then added by 35.45 grams per mole, which is the atomic mass or atomic weight of chlorine, times 2. So adding this, we have the molecular weight or the molar mass for magnesium chloride now is equal to 95.21 grams per mole. And so let us now proceed with determining the number of moles of a substance. So number of moles of a substance is denoted by small letter n, and we can determine the number of moles using this formula. N is equal to the given mass of the substance over its molar mass. So for example, determine the number of moles of 160 grams of sulfur. So our given substance is simply an element sulfur, and its given mass is 160 grams. So this is our given mass of sulfur, 160 grams. And for our molar mass, the one that we will be using is the atomic weight of sulfur, and that is 32.01 grams per mole. So we have now the mass and the molar mass, which is the atomic weight of sulfur. So the number of moles of sulfur now is equal to 160 grams all over 32.01 grams per mole. So as you can see, the unit of grams will be cancelled out, leaving us only with the unit of mole. And so the answer now will be 5.0 moles. That means in 160 grams of sulfur, there is 5 moles of sulfur. And so, after determining the number of moles, you can simply multiply this by Avogadro's number, and then you will be able to determine the number of particles of this substance. For our next example, we have determined the number of moles of 100 grams of carbon dioxide. So our given substance now is a compound. So which means we have to get the molecular weight of our compound carbon dioxide. The given mass of carbon dioxide is 100 grams. And the molecular weight for carbon dioxide or CO2 will be the atomic mass of carbon plus the atomic mass of oxygen times 2. So 12 for carbon plus 16 for oxygen, and then you have to multiply that by 2. So you have 44 grams per mole. That is the molecular weight of our carbon dioxide. That will be the molar mass of our substance. So using the formula for the number of moles, you have now 100 grams divided by 44 grams per mole. It will give us 2.27 moles. So this is the number of moles present, or the number of moles for 100 grams of carbon dioxide. Another problem here, but this time the number of moles is identified and we have to determine the mass of the substance. What is the mass of 25 moles of calcium carbonate? So the number of moles is given, and that is 25 moles. And then to determine the mass using the formula coming from the formula of N, we can determine the mass of the substance by multiplying the number of moles of the substance times its molecular weight or the molar mass. So we have to identify first what is the molar mass or the molecular weight of our compound calcium carbonate. So calcium carbonate is CaCO3. So we have 1 particle of calcium, 1 particle of carbon, and 3 particles of oxygen. So atomic weight or mass of calcium is 40 plus the atomic mass of carbon is 12 plus atomic mass of oxygen 16 multiplied by 3. And so the molecular weight of our calcium carbonate will be 100 grams per mole. So we can use this to solve for the mass of calcium carbonate. So we simply multiply the number of moles, 25 moles, times 100 grams per mole. So as you can see, the unit of moles will be cancelled out, leaving us with the unit of gram. So the mass of 25 moles of calcium carbonate is equal to 2,500 grams. So that is how we solve the mass of a substance given the number of moles. Now, it's your turn to solve these two different problems. The first one is determine the number of moles of 345 grams of potassium chloride, and that is KCl. And then the second problem, what is the mass of 15 moles of sucrose, C12H22O11. Use these atomic masses or weights to solve these two problems. So you may pause this video for a while, then solve it, and then let's see if you will get the correct answer, and later I will show you how to solve these two problems. So pause now the video and solve the problems. Okay, let's see if you get the correct answers. So this is the solution for the first problem. And here is the solution for our second problem. There you go, and I hope you were able to get the two correct answers in our two previous problems. So thank you very much for watching this lesson video. Please don't forget to like and share this lesson video to your friends and classmates, as well as don't forget to subscribe to my YouTube channel, Sir Mark Laroya. So thank you very much again, and see you again in our next video in this series of lesson video in AP Chemistry. I am your teacher, Sir Mark